Yeah. So what we discussed in the previous class, we understood about the Docker architecture, right?
Yeah.
Understood about the Docker architecture. One second. Desktop. W. So you understood about the Docker architecture, right?
Yeah.
So what this Docker is, guys, set 1 second. This session started. We join the call. Okay. So this is the Kubernetes architecture, right? API server, scheduler, controller, etcd. Okay. Yeah, 1 second. So Kubernetes, Kubernetes running nodes. So what is a Kubernetes, Srinivas?
No, no.
What is a Kubernetes?
Statement. Kubernetes is nothing but a prod and worker.
So Terraform is a infra orchestration tool. So Kubernetes is a orchestration platform. Orchestration platform. Yeah. So Kubernetes is a orchestration platform. What is this? To manage containers. To manage so containers. Developed by Google using Go language. Go language and Google donated Kubernetes to CNCF, Cloud Native Compute Foundation. Cloud Native Compute Foundation. So that K8 is first version released in 2015. Released in 2015. Okay.
Okay.
It is a free and open source. It's a free and open source. Okay. It's a free and open source. So Kubernetes use Docker internally. What Kubernetes use Docker internally? Using Kubernetes, we will manage our Docker containers. Nothing worry about it. So it's just a managing of the Dockers. Kubernetes will use Docker internally. Docker internally using K8s. We will manage our Docker container. So we will manage our Docker containers. Understood? So what Kubernetes will do? So Kubernetes will use Docker internally. Using Kubernetes, we will manage our Docker containers. We will manage our Docker containers. Is understood?
Yeah.
So what is a cluster? Cluster we already discussed about, right? What is a cluster? What is a cluster? Cluster is nothing but a group of nodes. So what is this? So this is a Kubernetes cluster. What this cluster contains? This cluster contains the control plane, worker node, and worker node. The group of nodes, the group of instance. A node is nothing but a instance. Group of instances is nothing but a group of instances is nothing but a cluster. Group of instances is nothing but a cluster. What is a group of nodes or a servers or a VMs or a VMs is nothing but a cluster. VMs is nothing but cluster. Master node, master node or nodes. Right. So master node and worker nodes. Worker nodes means our application will be deployed under the worker nodes. Who will manage that worker nodes? That worker nodes will be managed by the master node. Will be managed by the master node. A DevOps engineer. Who is a DevOps engineer or a developer will give the task will give the task to Kubernetes master node. DevOps engineer or a developer will give the task to the Kubernetes master node. Right. Master node will manage the worker node. So what it will manage? Will manage the worker node. So master node will manage the worker nodes. So will manage the worker nodes. Okay. So master node schedule will schedule the will schedule tasks will schedule the task to worker node will schedule the task to worker node. So our containers our containers will be created in worker node. So created in the worker node. Okay. So using cluster, we can achieve high availability. So what we will achieve, guys? We will achieve the using cluster. We can achieve high. We can achieve high availability. High availability. You can achieve the high availability. That's understood. So this is nothing but a Kubernetes cluster. Kubernetes is a very easy. Kubernetes is so very easy. So what is the architecture of the Kubernetes? So what is the architecture of the Kubernetes? What is the architecture, guys? So master node, right? So what is the architecture? Kubernetes architecture. So what is the Kubernetes architecture. What is the architecture? Master node and worker node. Master nodes, what will be available in the master node? So, for example, A is master node or control plane or manager node. So, master node or a control plane or a managed node. Okay. So, manager node, what we call it as. So, what is the scheduler? Scheduler will be the scheduler and API manager. Okay, API manager, HCD, control manager. Okay, only these four components will manage all the worker nodes. Okay, so in the worker nodes, what we call it as worker nodes. So in the worker nodes, what will be there? So worker nodes, what will be there in the worker nodes, guys? What will be there in the worker nodes? What will be there? Hmm. You see, guys. So in the worker node, pod, container, Docker runtime, kubelet, and kubeproxy. What will be there? Docker runtime, Docker runtime. Okay, pods. What is a pod? This is the new word. We don't know as of now. Okay, we'll let you know what is a pod. Next one is containers. Containers you already know. What is the next one? Kube. Kube proxy networking. What is that? Kube proxy is a networking. What is the next one? Kubelet. Kubelet. So what is a kubelet? Kubelet is an agent running on the worker node. So running on the worker node, if any container, if any container stopped or crashed, if any container stopped or crashed, this agent, this agent will inform to master node. This agent will confirm to the master node. So how to communicate with the control panel, guys? How to communicate? I already told you, right? How to communicate through the kubectl or a open lines. Through kubectl or a open lines. How to communicate with Kubernetes control plane. How to communicate with the Kubernetes with control plane. How to communicate, guys? So how to communicate with Kubernetes? Kubernetes will communicate with two ways. One is kubectl CLI command and kubectl. What is this? CLI tool. Okay. So we can communicate Kubernetes in two ways. One is GUI and other one is uh, what is that? So we can use open lens. It's a GUI tool, or we can use web UI dashboard. Web UI a dashboard, guys. So that this web UI dashboard is open lens. Okay, so we can use that web UI dashboard that is a open lens. Is understood? So you already know about the Kubernetes component architecture, master node, worker node, okay, HCD, API server, scheduler, kubelet, control manager, kube proxy, Kubelative, kubeproxy, so Docker engine, container, pod, right? It's a smallest building block that we will create in our Kubernetes run our container. Docker container will run inside the pod. As of now, you know only this. Okay. So what are the Kubernetes component? How to set up the Kubernetes cluster? You can set up the Kubernetes cluster. What is this, guys? AWS EKS setup. Right. So why EKS, right? Yeah. So something like Kubernetes, create a EKS setup by so step by step. So how we can set up the Kubernetes? So this is the way we can set up the Kubernetes. Step one and step two and step three, guys. So how we can set up? It will be very easy. So before that, why EKS? So what? How many types of Kubernetes we can use to set up this? Right. I will tell you that. Okay. Hmm, here only. So before that, I will tell you a case. No, I will tell you this way. You will understand. HCDQ prosty you already know, right? Architecture, cluster setup. Yeah. So K8 is cluster setup. So how we can set up the cluster? So there are multiple ways to set up Kubernetes cluster. There are multiple ways to set up the Kubernetes cluster. Self-managed Kubernetes cluster and provider-managed Kubernetes cluster. So what are the self-managed Kubernetes cluster and provider-managed Kubernetes cluster? Self-managed cluster means we have to set up the cluster of Kubernetes to run our application. Lots of command to install because of a self-managed Kubernetes cluster. So self-managed Kubernetes cluster, we have set up the cluster of Kubernetes to run our applications. To create a self-managed cluster, we have two options. We have a two options to self-managed and provider managed. So provider means who are the providers? Cloud provider managed, AWS, Azure, GCP, Oracle, IBM. These all are the cloud provider managed. So they are also provided the solution for the Kubernetes. We'll let you know that one. Okay. Self-managed cluster means we have to set up the cluster of Kubernetes to run our applications. Lots of commands to install. To create a self-managed cluster, we have two options. One is a mini cube. Mini cube is nothing but a single node Kubernetes cluster. This single node Kubernetes cluster will use on the development purpose. So in that single node only we can create the cluster. We can create the master. We can create the control plane and the data plane. Means so both the master and worker nodes in one node. That is nothing but a mini cube. That is for the development and R&D purpose in the they are using in the mini cube. So KubeADM. KubeADM is the multi-node Kubernetes cluster. What is that? These are the self-managed. KubeADM is the multi-node Kubernetes cluster. KubeADM is a tool designed to bootstrap a full scale of Kubernetes cluster. What is that? KubeADM is a tool designed to bootstrap a full-scale Kubernetes cluster. It take care of all heavy lifting related to cluster provisioning and automates the process completely. What is that? KubeADM is a tool designed to bootstrap. Cube ADM is a tool designed to bootstrap a full-scale Kubernetes cluster. Full-scale Kubernetes cluster. It takes care of all heavy lifting related cluster provisioning and automates the process completely. So if you use the mini cube, it's a single node cluster, right? We cannot lift the heavy loaded. But Cube ADM is a tool designed to bootstrap a full-scale Kubernetes cluster. It takes care of all heavy lifting related to cluster provisioning and automates the process completely. Automate the process completely. Setup. So Kubernetes cluster setup. Kubernetes cluster we can set up in multiple ways. So one is a self-managed Kubernetes cluster, KubeADM or Minikube, and managed Kubernetes cluster. So who are the managed Kubernetes cluster? Every cloud provider, they provided their own Kubernetes cluster. Those are AWS EKS, Azure AKS. So EKS is nothing but Elasticsearch Kubernetes service, Azure Kubernetes service, GCP Google Kubernetes engine, IBM IKE Google IBM Kubernetes engine, Oracle OKE Oracle Kubernetes engine. Okay, these all are the managed cluster. Managed means they already created that installed that Kubernetes, and they will give it as a service. Kubernetes cluster setup. So provider managed Kubernetes means will use Kubernetes cluster which is configured by someone. Provider manager cluster means we will use Kubernetes cluster which is configured by someone. So self managed means so we need to create our own. So we need to create our own. Lots of commands are to install. So that is nothing but a self managed. Provider managed cluster means we will use Kubernetes cluster which configured by someone. Elasticsearch Kubernetes service, Azure Kubernetes service, Google Kubernetes engine, Oracle Kubernetes engine, IBM Kubernetes engine. We can use it. Okay. So EKS by AWS. Who will provide this EKS, guys? AWS will provide the EKS, Elastic Kubernetes service, Amazon EKS fully managed Kubernetes control upline. Jason, Amazon fully controlled upline. AWS EKS. So Amazon EKS is a fully managed Kubernetes service on AWS, simplifying running containerized application by handling the complex control plane, complex control plane while letting you focus on your containers on EC2 or a serverless Fargate, offering scalability, reliability, and deep integration with the other AWS services for networking, security, and monitoring. It's a certified Kubernetes conformant, allowing easy migration and automate cluster management, patching, and scaling. So, what are the key features and benefits? Managed control plane, compute flexibility, AWS integration, scalability and reliability, Kubernetes so conformance and EKS auto mode. Okay. So what is a managed control plane? AWS manages availability and scalability of the Kubernetes master node, reducing your operational burden. So that so if you want operational burden, operation means we need to hire the DevOps guy to manage this one. So right, this burden will be taken care by the AWS. So compute flexibility, run workloads on Amazon EC2 instances or use AWS Fargate for a serverless experience without managing servers. AWS integration, seamlessly integrate with IAM for a security, ALB for the load balancing, VPC for the networking, and CloudWatch for the monitoring. And scalability and reliability provides high availability and auto scaling for both the control plane and our applications. Kubernetes conformance, compatible with the standard Kubernetes, so existing tools and applications work out of the box. So EKS Auto Mode offers one-click automation for provisioning the infrastructure, managing add-ons, and optimizing costs. So how it works? Cluster creation, worker nodes, and application deployment. Okay, so cluster creation, your request on EKS cluster and AWS provisions the high available control plane. Worker node, you choose initiative instances, managed or self-managed, or a Fargate for your container hosting node. So application deployment, deploy your containerized app onto the cluster, leveraging AWS services for load balancing and securing and storage. So why use EKS? Reduce the complexity, focus on apps, enterprise ready. Enterprise ready. So eliminates the time consuming task of setting up and maintaining the Kubernetes cluster. Focus on apps. Allow developers to concentrate on building and deploying the applications and not infrastructure. Enterprise ready, ideal for mission critical. It's a ideal for mission critical large scale workloads due to AWS robust infrastructure. Robust infrastructure. Yes, understood. So Amazon EKS, Amazon Elastic Kubernetes Service, build, run, and scale production-ready Kubernetes application easily across any environment. Easily across any environment. So why Amazon EKS? Amazon EKS enables a teams for any size or skill level build, run, and scale production ready application easily across any environment with AWS EKS Auto Mode. You can fully automate Kubernetes cluster management for compute, storage, networking with a single click. Amazon EKS empowers you to leverage open source innovations and breadth of AWS services while benefiting from the robust availability, reliability, and security of AWS infrastructure. Whether you are deploying AML workloads or modernizing existing applications or building new cloud native applications, Amazon EKS enables you to optimize for the performance, cost, and provides a consistent experience across cloud operation, cloud on-premise or exe environments. Okay, understood? So this is nothing but a EKS. This is nothing but a EKS. Understood? Nice, very good. Okay, understood? Yeah. So Kubernetes cluster setup, create one security group with the protocol A, all traffic, create a three Ubuntu servers using above created security group. So this security group, master node. So one master node with T2 medium instance, worker nodes too with the instances. Guys, this will be very difficult. So I will show you this, but the EKS setup is very easy and it's you guys just set up EKS with a minimal commands. The minimal commands. What those are? So it's a just so create a EKS management host in AWS. How you can create the management host? Launch new Ubuntu VM. Just launch the Ubuntu VM. Connect to the machine and install the kubectl and AWS CLI. Because of so this is the remote mission. What this is? This is the remote mission.
Do you have free trial for this case in
EKS.
AWS? Okay.
It's not a free trial. It will chargeable. But so recently it will be 200. So you will get the 200 credits, right?
Yeah.
So you can use it. Or if you get the billing, you just raise a request to the support team. I am just elaborating or learning the. I am a student. Learning the AWS EKS. So can you wipe out my billing? So they will
Oh,
automatically wipe out it. Okay. No need to worry about. You
okay.
just create a billing account. So you just create a support ticket to for wiping out your billing.
How many does they charge normally?
So yeah,
Any
that's the
idea?
reason. I will tell you. Normally $2-3 only.
Okay.
Okay. So not much bigger.
Okay.
No worries. But so you need to be cautious while creating and using it
Sure,
because
sure.
yeah. So it will be very easy. So cluster creation will take 5 to 10 minutes time. So we have to wait. After cluster created, we can check the nodes using the below command. And so we are done with the setup. After practice, delete the cluster and other resources we have used in the AWS cloud to avoid the billing. This is the most important. Okay. So after using it, every day, you guys can uh, stop this uh, stop this one. Okay, the cluster.
What is the purpose of creating a cluster,
Which cluster?
EKS cluster?
Yeah. So you you joined today, right? Yeah, that's the reason. So
Yeah.
what is the purpose? I will tell you here. So
Okay.
what is the Kubernetes? It's an orchestration platform to manage the containers. So container doesn't have the capability of the auto scaling and auto healing. So that's the reason Kubernetes came into the picture. Kubernetes. came into the picture, right? So to manage developed by the 30 minutes. Orchestration platform to manage the container developed by the. So why Kubernetes cluster, Varsha? To manage the to maintain and manage the containers. So containers doesn't have the capability of auto scaling and auto healing. That's the reason Kubernetes came into the picture. Understood?
Okay.
Okay.
Yeah. Yeah.
Yeah. So what you need a cluster is nothing but a group of nodes or group of instances. Okay. So this is the master node and these are the worker nodes. These worker nodes contain the containers, but container doesn't have the capability of auto healing. Means if the container is crashed, so there is no capability of a auto healing. Auto healing is nothing but a restarting. So there is no capability of a traffic is increases. I want to create another container, but so container doesn't have these features by default. So who will provide these features? So the Kubernetes will manage these containers. Will manage these containers. So how it will manage? If the container is crashed or if the container is dead, it will the so here a kubelet is there. That a kubelet is the agent of the Kubernetes. This Kubernetes agent will inform to the this master node. In the master node, we have a components called as a API server, scheduler, and kube etcd and control manager. So this kubelet will inform to the master node. Master node will again start the container. Again, it's auto scaling. So this will provided by the cluster. Understood?
Yes.
Yeah. So for creating the EKS cluster, what this is? So for creating the EKS cluster, EKS. What is EKS? Elastic Kubernetes Service. So Kubernetes are two types. One is self-managed and provider managed. Provider managed. So provider managed in the self-managed. So we can create a manually. So go to the AWS and you can launch that to three Ubuntu machines, right? So this is a self-managed. In the self-managed, so we can create a we can create the uh, mini cube, mini cube and cube ADM. What is this, guys? Cube ADM. So cube ADM is a multi-node cluster. Minikube is the single node cluster. Okay. So self-managed is very difficult. That's the reason every cloud provider they are providing their own Kubernetes service. They released as a Kubernetes service. What is that? EKS. What is that? EKS, AKS, GKE.
No, I had doubt.
Yeah. One second. GKE and OKE and
IKE.
IKE. Tell me.
Mini cube, it means single node cluster. Then what is the
Hmm.
use? What is the
Hmm.
purpose of that mini
Yeah,
cube?
for the development, for the development, they don't want to spend much amount for the Kubernetes. They are
Okay.
elaborating or they are doing the R&D for the Kubernetes or learning for the Kubernetes. Okay, so you can use one node. You can use one node and we can install the master that control plane and data plane in the one EC2 instance. And so you can just elaborate our knowledge or something like how we can do how it will work. Just you can use the mini cube. You can use the mini cube. It's just a single node cluster, Kubernetes cluster. So cube ADM. So we can use the cube ADM. So this is the cube ADM. If it is a
Multiple nodes.
self-managed.
Okay.
So it is a provider manager. So this needs to be done by manually. But if you are using a provider manager, just you need to execute a few steps. It will be very easy. I will tell you self-managed how it will be. So cluster setup. Create one security group and three Ubuntu nodes. Create three Ubuntu servers using the above created security group. Master node, one node, two worker nodes. Right. So Kubernetes minikube meaning. Minikube is one node Kubernetes cluster where master process and worker process both run on one node. Master process and worker process both run on one node. According to the official documentation of a minikube is a local Kubernetes focusing on making it easy to learn and develop for the Kubernetes. And prerequisites to use minikube is a Docker container or a virtual machine environment. Minikube provides you a way to easy deploying application on Kubernetes of learning and developing purpose even if you don't have enough resources like memory CPU. Now you understood why Kubernetes minikube? Srinivas?
No. Yeah.
అర్థమైందా? So
Mm.
minikube is a one node Kubernetes cluster where master process and worker process both run on one node according to the official documentation of a minikube. Minikube is a local Kubernetes focusing on making it easy to learn and develop for the Kubernetes. A prerequisite to use Minikube is a Docker container or a virtual machine environment. Minikube provides you to a way easily deploy application on Kubernetes for learning and developing purpose, even if you don't have enough resources like memory and CPU. You guys can follow this page and set up Minikube. You guys use this page. Okay. So what is a Minikube? Minikube quickly set up local Kubernetes cluster on Mac, Linux, Windows. We proudly focus on helping the application developers and new Kubernetes users. Okay, so just Kubernetes cluster architecture. So what is the Kubernetes? This is the AWS cloud. On the AWS cloud, you have a VPC. In the VPC, you have a three EC2 instances. One is a master, two is the worker node. So in the master node, what we need, so here, right, kube control manager, kube scheduler, kube API server, etcd, and kubelet, and kubelet. So in the master, in the worker node, so kube proxy, pod, container, right, kubelet, kube proxy. So this is the architecture of the Kubernetes. Okay, self-managed setup, Kubernetes self-managed setup. So take three Ubuntu VMs. One is master node, two worker nodes. So install Docker Kubernetes in both the master and worker. First, we need to install the Kubernetes and so Docker and install Docker and Kubernetes in both master and worker. So Kubernetes is nothing but a kubeadm. Install kubeadm, kubectl in the master node. Okay. So install, it will be very difficult, guys. Don't use that self-managed, but you just learn how it will be. These are the steps. You guys can go through these steps. Nothing to worry about. So it is recommended to run the command in the master node. So no, we can access the master node from the remote machine using the kubectl. Again, you can create a one node, and how we can access this is this Kubernetes. So there is a kube config file will be place it in our remote machine. How will communicate with each other? So we can communicate with each other through the kube config file. So what is a kube config? So here, so this is the EKS cluster. For example, provider EKS cluster. So how we can set up this EKS cluster? We can set up this EKS cluster. So you can just create the remote remote EC2 instance. So remote EC2 instance. So this is the Ubuntu or Linux, whatever it may be, guys. Ubuntu. Okay. So then install the EKS CTL and AWS CLI on this machine. You need to install EKS CTL and AWS CLI. Okay. So once it is done, install the EKS and AWS CLI. You see it, guys. So create a EKS management host in AWS. So launch a new Ubuntu. Okay. So connect to the machine and install the kubectl. So we need to install the kubectl and install the AWS CLI. So once it is done, install the ekctl. This is the kubectl, AWS CLI, and ekctl. Install the ekctl because of, so if you want to install the EKS, right, we need a ekctl also. So what you need to install? kubectl, ekctl, and AWS CLI. Why AWS CLI? To connect it from the to connect it from the EKS. Okay. So through CLI. Okay. So once you install this, right, you need to create the IAM role to attach the case management host. So creating a new role, you already know the new role, and add the permissions, IAM full access, VP2, VPC access, EC2, cloud formation, administrator. So then enter the role name called as a EKS EC2 role. Attach the created EKS management host to in the select EC2. Which EC2? This EC2. In this,
Master node.
not master node, remote. Still, we are
Okay.
not created master node.
Okay. Okay.
So this is for EKS setup. So EKS set.
Okay.
So for the EKS setup, still not at launched the EKS. Okay. Still not yet launched the EKS. Just you created the remote mission, created the remote instance. On that remote instance, just EKS CTL, AWS CLI, Cube CTL you need to install and create a role and attach this role to this. Which role you created? Which role you created? You created the role here. So what is that role? The role is EKS role EC2. Create this role and attach this role to this instance. Attach this role to this instance. So what role you created? You created the so created a IAM role and attached to EKS management host. This create a role and you can provide the IAM full access, VPC, EC2, cloud formation, administrator access, everything. And you just attach the EKS management host, select EC2 on security, modify ARL rule, attach this one. Okay. So once this is in the step one and step two are in the step one, step two will be running on the step one and step 2. So the step 1 and step 2 will be running on these missions, running on this mission. Okay. So step 3 also, everything will be run on this step only, but step 1, step 2 completed. So what is step 3? Create a EKS cluster using EKS CTL. On this mission, step 3, in the step 3, what you need to execute? You need to execute the commands. You need to execute the commands. Create a EKS cluster using EKS CTL. So, okay. So if you want to, so EKS CTL create a cluster name, create a cluster name. Okay. So name, which name you want to give it? For example, Blue Jay cluster or something like a region. So which region you want to, so which region you want to install, right? So this is US East 1 and US East 1B. We are installing zones, right? This will be installed on 2 zones. Okay, other Mumbai. So what is the TKS cluster? Create a cluster name, region, and node type, nodes, minimum nodes, and maximum nodes. We can provide it. Okay. Note cluster creation will take 5 to 10 minutes of a time. After cluster created, we can check nodes using below command. So which command? kubectl get nodes. So what is the command, guys? So command is the kubectl get nodes. Okay. So this is the way you just create the Kubernetes cluster. So the TKS cluster is created under the AWS. What this is? This is a case already created. This is the EC2 instance. If you want to connect this, so how you can connect it? So, kube config file. So there is a, so if you want to, how we can communicate from remote to EKS cluster? So we can communicate through the kube config file. Kube config a file. Which file? So you need to copy this kube config file in your remote machine. Okay. So then you can able to communicate with this each other. So if you run the kubectl command, which command is kubectl command, kubectl apply f pod.aml file. So once you run this command in the remote machine, once you run the, so once you run this command in this mission, once you run this command in this mission, so this will talk to the Kubernetes and will create the pod here. Will create the pod here. Guys, understood? So this will connect to the API server and store it in the etcd. You already know, right? Setup you already, right, guys? Understood? So API setup. I will show you the video. Okay, just a setup. I will ping you that video, guys. You guys can use that video and set up the mission. Okay.
Okay.
Yeah.
And if any case master node is down, what is the happening? What is the impact?
Good question. If master node is down, where I created that, you see. So this is the region of a US East 1. US East 1. Node to page T2 medium zones. So how many zones you created the, so in how many way zones you created the setup? EKS. US East 1A and US East 1B. So we are creating this EKS cluster setup in two availability zones, two agents. So if one is crashes, it will automatically connect from the second. Understood?
Okay. In both regions, same storage is connected.
Same story. There is same story is connected.
Okay.
So it will down.
Second one just ideal or
It's a secondary. It's a
okay.
disaster like something,
Yeah.
right?
Okay.
So it will automatically. So if worker nodes down, right, it will automatically create. But if the master node down, we have a. That's the reason we have a high availability.
Okay.
Understood?
If worker node down, then automatically create one more node.
One more node.
Okay. If space is not available, then how it is possible? For
Which one?
example,
In the master node.
one worker node is down. No. In master node there is no space, but one worker node is down. Then that worker node space is released.
Worker node is nothing but a EC2 instances.
Yeah.
EC2 instance.
Okay.
If one is down, right, it will
Yeah.
automatically create another one.
Okay.
We can create a number of EC2 instances, right?
Yeah.
The same with the same solution, it will automatically
Okay.
create the another worker node. If this one also down, it will
Okay.
automatically create the another worker node. Means it will launch the EC2 instance.
Okay. High availability.
High availability. So that's the
In
reason.
between,
So
is there any
Kubernetes is
possible to
a very
down
popular.
application?
Huh?
No, in between, for example, one
Mm,
work node is down within the seconds, one more work node will be created. But in
creating. Yes,
between,
yes.
yeah,
That is
in
the
between any
biggest concept
application is
in
down,
replication.
any impact for application in between creating and configuration, like
No, immediately it will create it. Yeah, definitely. If application is down, so
some a few seconds maybe it will impact.
it will impact.
Okay.
But here you see, right?
Yeah.
So there is no storage needed. There is no big storage needed because of initially. So what you are working on it, right? Linux servers. So while doing the Linux server patching, they are creating a snapshot or a memory snapshot or a normal snapshot.
Yes,
So for
yes.
creating multiple snapshot, we need a storage, right? So
Yeah.
why we are creating this? If in case if we deleted, if we crashed this one or something goes wrong. But here, if something goes wrong, immediately it will create the another one. If something goes wrong, immediately it will create the another one. There is no storage needed. So
Okay.
many big advantages are there in Kubernetes. So microservice based architecture, something like a auto healing, auto scaling, everything will be available in the Kubernetes. So that's the reason Kubernetes is very popular. So no need, right? No need of a server, just container is enough. No need of a backup, right? Already the images, if everything is goes wrong, I want everything. So it's already that Docker images are already available in the Artifactory. These are not a big deal. This is a minimum. So within 1 GB, the Docker containers are available. If you have 100 Docker containers, so only 100 GB. But if
Yeah.
you take the snapshot of the EC2 instance or a VM, it might be a 100 GB or it may be a 500 GB, it may be a 1000 GB, right?
Yes, yes.
So this is a
How much the root file system it is there, we need to take the same size
we
of
need to this next
snapshot.
snapshots,
Yeah.
right? So that's the reason. That's the reason. So they overcome all these things and created a Kubernetes. If
Like
you concentration
simple
on Kubernetes, right, it will be
example, yeah, zip file.
Unify. So that's the reason Kubernetes is most popular, most popular. So if you learn the Kubernetes, right, so you will sustain at least next 5 to 10 years. Okay, because of every application they are migrated from on-premise to on-prem to cloud, right? And so they are using so servers and something like right the servers and everything. So everyone is trying to migrate their application from monolithic to microservice. So the microservice they are providing easily EKS. Okay. So in the EKS, so it will be very easily manageable. Easily manageable over worker nodes, everything. Worker nodes are master nodes. So why EKS? Easy maintenance. Easy cost upfront, cost reduction. Everywhere EKS came into the picture. Not only EKS, whatever the cloud providers, right? Provided that one. Understood? Huh?
Yeah.
Yeah. So we can access the master node from the remote mission using the kubectl. Using the kubectl here remote mission. Then once you connect, you click the kubectl, right? Master node will connect and it will deploy it on the worker node. So it will deploy it on the worker nodes. But it is in the EKS, in the EC2. In the EC2, you need to install the EKS CTL and kubectl. So if you want to connect this Amazon EKS, right, you just connecting from this EC2 to EKS. There is a control plane. In the control plane, there is a master node, worker node, right? Kubernetes master node. So master node having the controller and API server, kube scheduler, etcd, and apart from Cloud API manager also there. So, right? This will connect to the kubelet, kube proxy, container runtime, everything. This is the worker node architecture. So this is the new VCT. Kubernetes core components, Kubernetes resources, objects, workloads. So what are the resources? Container, Kubernetes container, pod, namespace, service, deployment. So what are those guys? What are the components? The Kubernetes resources, objects, workloads are the components. Container, pod, namespace, service, deployment, replication controller, replica set, daemon sets, persistent volume, stateful sets, role, and secret config maps. Secret config maps. Guys, tell me. Srinivas, can you speak out? Can you read this?
Which one?
This one.
Kuber
Container, pod,
container pod namespace service deployment replicant controller
application
replicant
controller,
replication set
replication,
replication controller replication set daemon
daemon
sets
sets,
daemon
daemon
sets
sets,
persistence volumes
volume, stateful sets,
stateful sets role
rules, and secret config maps.
secret config maps.
Vausha, you can read this. You
Okay.
already know, right?
No, I only know means some things role
Okay.
container,
Okay.
not all the things. So
Yeah.
container
Speak out.
namespaces, service deployment, replication controller, replication
Mm,
set, daemon
mm,
sets,
mm,
persistent volumes, stateful
mm,
sets, role,
mm,
secret
mm,
config maps.
mm. So, what do you know in this list? Srinivas and Vausha.
Service, role, container,
Mm.
only
Srinivas,
those
what
are.
about you?
I know
Me,
volume, but persistent volume, don't know.
Mm,
for me, container and role only I know.
mm,
Service means which service, like in
mm. So you don't know that service.
yeah,
Pod also new to you, right?
yes,
Pod.
yes, yeah.
Namespaces you don't know. Service you don't know. Deployment you don't
Container
know.
also in
Replication,
Docker time only, I know.
you know, container. And the
Yeah.
stateful set and stateless sets also we discussed about in
Yes,
the
yes, yes.
container, right?
Yeah.
You know only
Yes.
that persistent volume also we discussed in the that Docker.
Docker
We
time
can
only.
create
Yeah.
the bounded volumes and container volumes, right? That is nothing but a
Yeah.
persistent. Persistent volume means so whatever the storage we can use the for the databases, so that we call it as a persistent volumes. Okay, you just know only container and the stateful sets. Stateful
Volume
set
is like hard disk. We create volume from
volume is nothing
yeah,
but a hard disk. Space
yeah.
or storage, right? That is nothing but a persistent volume.
Hmm.
Okay. So, yeah. So these are the main concepts in the Kubernetes. What is this? So main concepts in the Kubernetes. You guys can read these 10 times. Okay, 10 times or something like. So every time we can connect so each and every topic and we discuss in the Kubernetes. Okay. So
Okay.
container, you
Yeah.
already know the container. Pod, what is a pod? What is a namespace? What is a service? What is a deployment? What is a replication controller? What is a replica set? Daemon sets, persistent volumes, stateful sets, roles, secrets and config maps, Helm charts, Helm also we can discuss. Okay. So we are using Docker to create the container for our application. Docker will use it to runtime engine to Kubernetes cluster. Kubernetes is used to manage our Docker containers. Kubernetes will manage our containers, but no directly. It will use pod to manage the container. So we are using Docker to create a containers for our application. What is that? A Docker engine. Docker will be used as a runtime engine in the Kubernetes cluster. But Kubernetes is used to manage our Docker containers. Kubernetes is used to manage our Docker containers. Kubernetes will manage our Docker containers, but not directly. It will use pod to manage the container. So directly it will not manage the containers. It will use pod to manage the container. So pod is the smallest building block which we can deploy in Kubernetes cluster. What is that? Pod is a smallest building block which we can deploy in Kubernetes cluster. Containers will be wrapped under one unit. One unit call it as a pod. What is that? Containers will be wrapped under one unit call it as a pod. In Docker, container is the smallest part that we can deploy, whereas in Kubernetes pod is the smallest part we can deploy. To get Tarify on pods, we need to understand the namespace first in the Kubernetes. Okay. So this we'll discuss tomorrow. Okay. What is a pod? I already told you, right? So what this is a manifest file. So API version kind metadata spec. In the spec, we are discussing about the containers. So this container images, we can specify the artifactory. Artifactory. So I will tell you. One manifest example for Kubernetes include JFrog artifactory. You see, guys. So API version. This is the for the Kubernetes. So what is the kind? Kind is nothing but a deployment. What is that, guys? Kind is nothing but a deployment, guys.
Yes, kind.
Hmm. So what are the components are there? Kind equal to pod, kind equal to namespace, kind equal to service, kind equal to deployment, kind equal to replication controller, kind equal to replica set, kind equal to daemon sets. Okay. So these all are the kind. Guys, understood? So kind is nothing but a what we are specifying, which component. Metadata namespace equal to my app ns. I will tell you what is namespace. Okay, spec replicas, replication controller, replica set. Replica set is one, and so this is a replication replica set. We can use the replica set. What is the difference between replication controller and replica set? Older days they are using the replication controller. Now we are using the replica set. So every time only one part need to start, right? So spec container, my container. This container will be this container. This Docker image will be where the Docker image is available. The Docker image is available under the our JFrog. So we are specifying the Docker image location. Where the Docker image location is available. The Docker image location is available under the Artifactory. JFrog Artifactory. Right. So port 80. So image pool secrets. This is the secrets. This is the container. This is the one YAML file. This is the one YAML file. So once you click this is the one YAML file. What you need to do? So this YAML file is my app dot YAML. My app dot YAML. This is YAML file. Right. So this YAML will be using kubectl. Like I want to apply this image on my Kubernetes cluster. Kubectl apply F. So what is that? My app.yaml. So if you run this command, right? If you run this command, if you run this command here, if you run this command here, so it will talk to the API server. API server will talk to the HCD. We can store the information. In the HCD, the scheduler will check the HCD. So is there any new information is available? Yes, new information available. It will talk to the controller. Controller will schedule it, and scheduler will run that, and we can create the container here with the kubelet and Docker container. These are very easy, guys. Nothing to worry about it. So we need to discuss. So kind equal to deployment, kind equal to pod, kind equal to service, kind equal to service, kind equal to replica set, kind equal to replication controller. So this we'll discuss.
Sir,
Hmm.
deployment means what? If we create any server on that, we deploy any code means we insert that through the
Yeah.
commands.
So if we
We
use the deployment, if you use the pod, kind is nothing but a what type of service, what type of components you are using and creating. Here, here we are creating the pod. Here we are creating the service. Okay. There we are creating the deployment. If you use the pod, if you use the kind as a pod, what it will create? If you use the kind as a service, what it will create? If you use the service, right? This is service. Yeah. So if you use this kind equal to replication and controller, what it will create? So right. So if you use this kind equal to replica set, what it will create? Yeah. So if you use the deployment as deployment as a kind, so Kubernetes a big advantage. This is the so it will automatically deploy. No need to manually run anything. If you use the deployment, the strategies are recreate and rolling update. So if you use the deployment as a file, deployment as a kind, it will automatically deploy the application. A rolling update as a recreate. Okay. I will tell you. I will tell you everything. No worries. Config back secrets. Stateless, stateful, Helm chat. So Helm is nothing but a package manager. So how we are installing the package in the EC2 instances? Same way, we want to install the package on Kubernetes. How we can use? We can use the Helm chat. Helm chat to install the packages.
okay.
Install the packages on a Kubernetes that pods containers, right? We can use the Helm. Okay. So chat repository, Helm client, API server, Kubernetes cluster. So we'll discuss about the Helm. Prometheus is Grafana, ELK. Okay. So auto scaling and horizontal pod request, and this is the limits and CPU limits and request, EKS. Okay. Ingress controller. Then we'll discuss the GitLab or Git, how CI/CD works. Then we'll discuss about the Jenkins. So how we can deploy the application, not manually through automation. Okay. So we'll discuss these things. Through the Jenkins pipelines, you can use them. Okay. Meghna, you just joined, huh?
Yeah.
Yeah. Actually, what we concluded is, so we concluded, so we are wind up the class today. Tomorrow we will discuss that components. I think you already know the components, right?
Yes, yes.
Yeah, we'll discuss tomorrow. Already know how to install the TKS also, right?
I will have to
You need
brush
to
up.
check it
I
again, huh?
don't
So real
particularly.
time,
Yes,
you are
yes.
working currently, right? You are working on a Kubernetes, something like.
Yes, yes.
So, so you can check it how it will relate, and you can create a one document. So how they are working in our environment. So after ending of this session, you can take a one session for how it will works on your in our organization. I will show you my organization also. You can show your organization also. Okay. Then people know in the real time two times, two environments.
Yeah,
Yeah. Just overview. So I will also show you.
yeah.
So, but this for this guys, you guys need to come to office. So Meghna will show you their real-time environment, and I also show you my real-time environment.
Without
Okay,
recording.
without record.
What
ఓకే
about tomorrow class, Anna? What time?
ఉంది టుమారో కూడా సేమ్ ఈ టైం తీసుకుందామా లేకుంటే ఈవినింగ్
No problem. Anytime for me.
మేఘ్నా వాట్ అబౌట్ యూ సో విల్ టేక్ టుమారో 2 hours గైస్ అట్లీస్ట్ సో వీ నీడ్ టు డిస్కస్ పాడు నేమ్ స్పేస్ సర్వీస్ deployment or replication control at least 3 4 we need to discuss 3 4 concepts. If
Okay.
you're okay with 2 hours, we will take 2 hours tomorrow.
Yeah, sure.
Okay, the same
At
timings,
which
9 to
time?
11. 9 to 11. Is it
No.
okay for you guys?
Okay.
Srinivas, okay na?
Yeah, for me, fine. Remaining people, check with them.
Varsha, Meghna, 9 to 11 okay na?
Yeah,
Yeah.
it's fine.
Yeah guys, thank you. So we'll continue from tomorrow.
Sir, I
Hmm.
one question is here for me. That we create one EC2 instance. On that EC2 instance, suppose I install one Java application.
Hmm.
Okay.
Hmm.
After that, we need 100 EC2 instance. For that, what kind of means we can use manually? We don't install the application one by one EC2 instance. Automatically, on 100 EC2 instance, we need the Java application. For that situation, what we do?
Here, right? Here you're asking about EC2 now.
Yeah.
If you're asking about Kubernetes, there is a concept called as a replica set or replication controller and auto scaling. Okay, if you use auto scaling and replication controller, how many Java applications you need to run on the same machine? Something like if traffic comes right. Initially, also we discussed about the auto scaling, EC2 instance auto scaling. If traffic comes through the load balancer, yeah, based on the CPU memory, here also based on the CPU memory, if CPU reaches 30%, it will automatically create the another container or a
One
pod.
EC2 instance. Yeah.
No, pod. Here, pod container.
No.
If there is no space in the EC2 instance, it will automatically create the another EC2 instances on the master node. Master node will take care of all
No.
these
My
things.
question is not
Hmm.
about the space or anything else. Just only we do one thing on one server, then automatically other servers will that do that one work.
Space. So,
We just host any website on one server.
website we hosted website in here, right? We hosted the website here. Yes, this is the Java application. This is one container. This container having these are the multiple containers having the Java application. Okay, next the you are asking about the logs, storage. If it is a storage, we can directly connect to the S3 bucket and we can store the container cannot store the data, right? It will store the data in the S3 bucket. Or if it is a database, you can connect as a bind mounting in the EC2 instance. So for that, so it will automatically extend it, or we can use the S3 bucket for the storage purpose also. So S3 will automatically extend the storage, right? Extend or increase the storages without manual intervention. So you are asking about the storage for which purpose? Multiple application Java applications running on the containers. Multiple containers.
Okay.
Okay. Yep, guys. Thank you. We'll continue from tomorrow.
హరి గారు అది
Hmm.
పీపీటీ రిఫర్ చేస్తున్నారు కదా దాన్ని ఏమైనా షేర్ చేయడానికి అవుతుందా మీకు?
ఉంది కదా, మీకు ఆల్రెడీ చెప్పాను కదా నేను.
లైక్
సో మన
మీరు
దాంట్లో
షేర్
సో
చేసిన
మీరు ఎక్కడికి
డ్రైవ్.
వెళ్ళి
ఓకే.
ఇక్కడ సేమ్ జస్ట్ ఈ రిపాజిటరీలో AWS దీంట్లో ఐ ఆల్రెడీ అప్లోడెడ్ ఆల్ ద డాక్యుమెంట్స్. ఇక్కడ మీరు చూస్తే
ఓకే ఓకే నేను చూస్తాను.
చూసుకోండి, ఇక్కడ అన్ని ఆల్రెడీ అప్లోడ్ చేశానండి. ఓకే. Thank you guys. Thank you.